According to the National Electrical Code, specifically Article 300.3c, sharing a nipple for branch circuits with feeder wires is prohibited. The rationale behind this prohibition lies in the potential for interference between feeder and branch circuit conductors. Feeder wires, due to their function, often carry higher currents. These higher currents can generate excessive heat. This excessive heat, if not properly managed, could negatively affect the insulation and overall performance of the branch circuit conductors. Maintaining separation between feeder and branch circuits is crucial for ensuring electrical safety and adhering to code compliance standards. Therefore, sharing the same nipple in a double panel with feeder wire for that panel and branch circuits is not permitted by the NEC. The recommended practice involves drilling a separate hole and installing an additional nipple. This physical separation effectively isolates the feeder wires from the branch circuit conductors, mitigating the risk of interference and heat transfer. While implementing this separation, it is essential to use appropriate bushings or grommets. Bushings and grommets serve to provide proper insulation and mechanical protection for the conductors as they pass through the metal enclosure. This protects the conductors from abrasion and potential damage that could compromise their insulation integrity. The National Electrical Code provides detailed guidelines for electrical installations to ensure safety and prevent electrical hazards. Understanding and adhering to these guidelines is crucial for all electrical work. Firstly, conductors must be insulated. Insulation prevents unintentional contact between energized conductors and grounded metal parts, reducing the risk of electric shock. Secondly, overcurrent protection devices, such as circuit breakers and fuses, should be installed in each circuit. These devices protect the wiring from excessive current flow, which could lead to overheating and fires. Thirdly, all metal enclosures and equipment must be properly grounded. Grounding provides a low-resistance path for fault current to flow back to the source, tripping the overcurrent protection device and preventing electric shock. Fourthly, wiring methods must be appropriate for the environment. For example, in wet locations, conductors must be installed in waterproof conduit and fittings. Fifthly, electrical work must be performed by qualified personnel. Only individuals with the necessary training and experience should perform electrical work. The National Electrical Code addresses specific requirements for conductor sizing and overcurrent protection. Conductors must be sized to carry the anticipated load current without overheating. The ampacity of a conductor is determined by its size, insulation type, and ambient temperature. Overcurrent protection devices must be sized to protect the conductors from overload and short circuits. The size of the overcurrent protection device must not exceed the ampacity of the conductor it is protecting. The National Electrical Code specifies the number of conductors that can be installed in a conduit. The number of conductors allowed depends on the size of the conduit, the size of the conductors, and the type of insulation. Overfilling a conduit can cause overheating and damage to the conductors. The National Electrical Code provides requirements for the identification of conductors. Grounded conductors must be identified by white or grey color. Ungrounded conductors must be identified by a color other than white, grey, or green. Equipment grounding conductors must be identified by a green color or a green color with one or more yellow stripes. The National Electrical Code specifies requirements for the installation of boxes and enclosures. Boxes and enclosures must be sized to provide adequate space for the conductors and devices installed within them. Boxes and enclosures must be securely mounted and protected from physical damage. The National Electrical Code provides requirements for wiring methods in different locations. In residential occupancies, non-metallic sheath cable, commonly known as Romex, is often used for branch circuits. In commercial and industrial occupancies, rigid metal conduit, intermediate metal conduit, and electrical metallic tubing are commonly used. The National Electrical Code addresses requirements for specific types of equipment such as lighting fixtures, appliances, and motors. Lighting fixtures must be installed in accordance with the manufacturer's instructions and the requirements of the NEC. Appliances must be connected to a branch circuit with sufficient ampacity to handle the load. Motors must be protected by overcurrent protection devices and motor overload protection. The National Electrical Code is updated every 3 years to reflect changes in technology and industry best practices. Staying current with the latest edition of the NEC is essential for ensuring electrical safety and code compliance. The NEC is not a design manual, but rather a set of minimum safety requirements. Electrical designers and installers must exercise sound engineering judgment and follow industry best practices to ensure a safe and reliable electrical system. The NEC provides guidance on the proper selection and installation of electrical equipment. Selecting equipment that is listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories, ensures that the equipment meets established safety standards. Proper installation of electrical equipment is crucial for ensuring its safe and reliable operation. The NEC addresses requirements for electrical inspections and testing. Electrical inspections are conducted by qualified inspectors to verify that electrical installations comply with the requirements of the NEC. Electrical testing, such as insulation resistance testing and ground impedance testing, is performed to verify the integrity of the electrical system. Understanding the principles of electricity is essential for safe and effective electrical work. Electricity is the flow of electrons through a conductor. Voltage is the electrical potential difference between 2 points. Current is the rate of flow of electrons. Resistance is the opposition to the flow of current. Ohm's law states that voltage is equal to current times resistance, volts equals amps times ohms. Electrical circuits can be either series or parallel. In a series circuit, the current is the same through all components. In a parallel circuit, the voltage is the same across all components. Electrical power is the rate at which electrical energy is used. Power is equal to voltage times current. Power equals volts times amps. Electrical energy is measured in kilowatt-hours. 1 kilowatt-hour is the amount of energy used by a 1000-watt device operating for 1 hour. Electrical safety is paramount when working with electricity. Always de-energize circuits before working on them. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. Never work on electrical equipment in wet conditions. Be aware of the potential hazards of electricity and take precautions to avoid them. The NEC specifies requirements for arc fault circuit interrupters, or FSIs. FSIs are designed to protect against electrical fires caused by arc faults. Arc faults are unintentional electrical discharges that can occur in damaged or deteriorated wiring. FSIs are required in many areas of residential occupancies, such as bedrooms and living rooms. The NEC addresses requirements for ground fault circuit interrupters, or GFCIs. GFCIs are designed to protect against electrical shock. GFCIs detect ground faults, which are an intentional electrical pass from a hot conductor to ground. GFCIs are required in wet locations such as bathrooms, kitchens, and outdoor areas. The NEC provides requirements for surge protection devices, or SPDs. SPD are designed to protect electrical equipment from voltage surges. Voltage surges can be caused by lightning strikes, power outages, and other disturbances. SPD are recommended for sensitive electronic equipment, such as computers and televisions. The NEC addresses requirements for energy efficiency. Energy-efficient lighting, appliances, and equipment can reduce energy consumption and lower utility bills. The NEC encourages the use of energy-efficient technologies. The NEC provides requirements for renewable energy systems, such as solar photovoltaic systems and wind turbine systems. Renewable energy systems can generate electricity from sustainable sources. The NEC addresses requirements for electric vehicle charging stations. Electric vehicle charging stations provide electricity to charge electric vehicles. The NEC specifies the requirements for the installation of electric vehicle charging stations. Understanding the NEC is essential for safe and compliant electrical installations. Consulting with a qualified electrical contractor or engineer can help ensure that electrical work is performed safely and in accordance with the NEC. The NEC is a complex and comprehensive document. Taking the time to study and understand the NEC can improve electrical safety and prevent electrical hazards. There are many resources available to help understand the NEC, including online training courses, seminars, and publications. Continual learning and professional development are essential for staying current with the latest electrical codes and standards. Electrical safety is a shared responsibility. Everyone, from electrical contractors to homeowners, has a role to play in ensuring electrical safety. By following the NEC and practicing safe electrical work habits, we can reduce the risk of electrical accidents and protect ourselves and others from harm. The NEC is a living document that is constantly evolving to meet the changing needs of the electrical industry. Staying informed about the latest changes to the NEC is essential for ensuring safer and compliant electrical installations.